Hello everyone, my name is Elvira Rakova and today I would like to show you an example of engineering project that you can face while working with the compressed air systems. Honestly, every day it's still surprising me what kind of application we can find. And here I had to design and calculate an anti-ice air bubble system. So basically, it is installed in the gate of the river, and it had to prevent the icing uh, using air bubbles. For that, I've been provided with the scheme of this gate. And here there are ideas were proposed to install the compressor, maybe with one compressor, with the two compressors. So I got a very big explanation of the system, how it has to look like, and what are the also challenges with this. And the idea was to calculate the diameter of the tubes, the diameter of the orifices, as well as the consumption, required pressure levels, and so on. So I just want to tell you that it was just an engineering of the compressed air system without the flow dynamic analysis. This would be making it more complicated, but because those systems already working and installed, and there is already some certain practice on that and the standards, also on the amount of the flow that is required per meter. This was the thing where I started. So now I would like to show you how it is possible to do with the easy CAS. Uh, you can think that it can take about days or weeks, but actually it can take a matter of days to calculate required parameters and see various things. First thing is, of course, that we need to work with we should work with the ambient conditions. We work under water. And this is very important to remember that the input parameters, when we go here, we need to put the pressure level outside of the system. So it's not an ambient pressure, but dependent on the depth where is it installed. One of the requirement of these calculations were also to estimate various consumptions and minimum and maximum consumption for the various depth of water. And of course, this is extremely important to remember. After that, we put here one compressor, the tubes that were already pre-installed there, and diameters of the tubes that are for the bubble system itself that are below the water surface. And the model of the orifice can be used as the model of the blowing tube, or it's just like a hole, let's say, with a certain diameter and certain length that is presented by a width of the or thickness of this wall. After this, we have also the pressure that we require to have here. To calculate also this pressure, I created before a model of this orifice just to see what is the requirements and how I can meet those requirements. So I found this pressure level that is would be perfect. And after this, starting from the consumer, I want to calculate the system behind. So here I put the length. It was about 45 meters length, 87 or 88 orifices. So for this, it took around 30 minutes to create this model. And here you already can see that it calculates the required pressure of the compressor. So it's the compressor with the low pressure, 2 bar, the flow rates it is required also here. The cost, how much it's going to be cost, the operation, and of course, what is the CO2 footprint for the operation of the system. On the other hand, we also can see the diameters of the tubes. So I put, because we work with the very low pressure levels, at the compressor, I put the higher optimization criteria here. So we can put, let's say, 0.1 bar. And here, then we can see if we need to change the tubes, or in this case, it shows, for example, only one tube here. We also could do other models, such as, for example, with the two compressors or various operations, for example, when the diameter of the tube is different, diameter of the orifice is different, where the distance between is different. So here, for example, is the model with the two compressors. And so I have one compressor on the other side. And here is the same idea that we can calculate the flow rates and pressure levels for that uh, for that application. So in this case, for example, we had the higher diameter of the orifice. Before it was 1.5 millimeters, here is 2 millimeters, and you can see how dramatically it's already changed the consumption of the compressor. We would think, okay, just a half a millimeter hole higher, bigger, but it's twice as much required flow rate, as well as the pressure level is 2.2. Sorry, here I showed you again the one compressor, but I also have the model for two compressors. And for example, let's say here, and here you can create the table of various applications of various tube diameters to understand what is going to be the uh, optimal operation and what is going to be the optimal compressor. So here, for example, we have two compressors, and the interesting part of this project was that when the customer asked me, he said, I want to have this compressor and calculate me how the system should look like. But actually, it's very important first to calculate how the system should look like and how the system should operate, to have also the compressors that will operate the system, to choose those compressors, because it's always essential to start with the consumer calculation rather than the compressor calculation. So, because if we have the whole diameter here of 2 millimeters, it will under the, for example, 2 bar that we have in the system, it will always require this flow rate. And this depends on the geometry of the system. So this is simply the thermodynamics of the system. So we cannot just have the compressor with a certain pressure level and a certain flow here, and then hope for the best in the consumers. So after this, you also can understand what is the, for example, after this, you also can understand the various impacts on the quantity of the orifice and as well as the diameters flows depending on the depth. It can be calculated for various depth, for various ambient pressure. Maybe one day you want to calculate application for Mars, for other planet in the universes. And this project took about 3-4 days to establish the models. I mean, it was 2 days to understand the technical requirements of the system, or one day just to understand it and to put it in order, and around like maybe one day all these calculations, and then it can be easily integrated into the report. You will find also the link to download the model for this project, just to play around and to understand how the various ambient pressure level can impact the calculations, how they can impact the in general operations. And you also can download the EasyCast software to play with these models.